Oh, we were just starting and Tuco's already trying to change the title. Let's change that back before he, I think he did that last time. For a while there was a bunch of unnecessary punctuation in the title of the video because I think Tuco likes the keyboard of the machine that I usually run that part of the stream from. Oh, welcome back to the stream, everyone. I'm going to briefly check to make sure all the scripts and doodads are running, which is kind of what this stream is related to, but I'll get more into that in a sec. I've got all this infrastructure so that I can send the streams to different destinations, and I think this is the first time I've used this particular one since setting it up, which is just for stuff that goes only to YouTube and not to the Twitch for Senryo. Also have a much longer wire. Well, it's not that much longer, but it's like longer enough for TucoCam that it's a little easier to maneuver this around the shop. This is that same SDI camera that I made a little excursion into looking at during the last stream, but now I've actually got it mounted properly on a tripod with a long enough extension wire that I can use it to follow around the cat. So speaking of things that are farther away from the desk in the shop, I have the desk cleaned off right now since this ominous looking thing is actually the subject of the current stream. Oh, let's move this around without knocking over any tea. That would be terrible. And I've got this set aside. This is the glitching rig we've been working with, which is actually at a pretty interesting point. I don't know, some of you might have tuned into some streams previously where I'd been sort of playing whack-a-mole with electrical issues on that. And I think I got that to the point where it was pretty reliably, I could pretty reliably get the processor into one of two states upon starting up. Either I could successfully use a voltage glitch to break out of a loop, which is the particular test I was trying at that point, or it would, maybe about half the time, the processor would just totally fail to bring up Ethernet entirely. So I was debugging that for like today and like most of yesterday, and it's still a super weird problem. And I've noticed some differences in the initialization states, and it basically boils down to something which I think is possibly either a subtle bug that has always existed in the Ethernet driver for this chipset, or maybe more likely a subtle bug that I've introduced via some of the hacking around I've done on the Ethernet driver. And I've tried to investigate both possibilities. Haven't really been able to nail anything totally down. Found some interesting leads, but it's also been looking enough like an issue that's specific to this particular test firmware that it's convincing me that I've pretty much, squeezed all of the useful stabilization experiments I can out of this particular setup, and it's time to move on to the next experiment. So that seemed like a good time to actually take an evening off and do a short video, partially since it seemed like a short, well, not necessarily a short video, but a short project that could fit in maybe a couple of videos instead of like a million. And so some of you might have seen, I have it over here. I'll throw it on the camera in a sec, but there was a little flexible button doodad that I made in a previous stream in order to kind of direct the cameras and things. This is kind of in the same vein. I want to make a little utility to make some of the just some of the mayhem of managing all of these video recordings and streams and stuff a little bit more manageable. So one problem I often have when I'm trying to both do the stream and to do the recording for other projects, or for concise versions of the videos later, or for using that footage for other things later. A lot of the time I'll have another video recording setup going simultaneously, but I don't always want to do that because that just wastes a lot of hard disk space. So there's usually some element of managing those recordings. And that happens, for reasons of resource usage on a bunch of different computers. So it would actually be really nice if I just had some kind of little widget that I can see easily while I'm recording that would show me the status of both the streams and the recordings and anything else that I need to keep track of while I'm running this mayhem thing. And so, I could just throw a monitor on this. There's like a Linux box that manages, that actually runs the stream on Nginx, and that's probably where I'll write the code behind this. And so I could just plug a monitor into that machine, but I'd actually prefer to have something that is both more legible and smaller than a monitor. So this seemed like a good opportunity, by way of long-winded introduction, to revive an old project. So the old project was actually, it originally started as a separate thing, but then as a lot of my projects, especially around that time period, it sort of merged in with a bunch of other things I was working on and became something kind of epic that I would never actually complete. So the small version of this was called the Media infra-widget 6000, or the MI6K for short. Let me change angles so you can get a better view of this Tuco fetch. Oh yeah, and today, of course, is one of those videos where I do want to actually make sure that with a lot of the voltage glitching stuff, it's been this kind of meandering process where, I want to get a sufficient sampling of B-roll from the important steps along the way. But it's likely that when I actually make a final video about that, the footage I end up using will be pretty sparse. So it's not as big a deal if I forget to record every little thing. Whereas in something like this, and that's also, I'm using the headset mic today, I'm probably going to be able to just edit, a couple of streams down into an actual concise video later on for this project if it actually works out. Or if it doesn't, it'll just be a different video. So yeah, this sort of turned into an archaeology expedition with a little bit of design mixed in. Since the thing that I want to design is actually not too complicated, I basically want to repurpose a really nice vacuum fluorescent display from an old project. It was something that I originally picked up in a surplus catalog, BG Micro. I wonder if they're still around. Last I checked, they were. Still had some cool stuff. So yeah, they had this really beautiful character VFD, like you might find on, I don't know, a cash register or something, but, capable of text, really nice and bright. Not the hugest thing, it's like 16 by 2 or 20 by 2 characters, but the information that I need to display is pretty small. I basically have, maybe half a dozen things at most that I care about at any given time that I basically just need to know, are they running, and maybe how fast are they running. So the way I'd imagine doing this is having little, couple of letter long codes for all the kind of interesting things that I'm monitoring, and then having like, a bit rate or something that it displays, or like an icon that twiddles, or, if I can even get audio levels on this thing, I could do a very simple VU meter. But I'm not sure it's going to have access to audio information because that's done on a totally separate machine. And I could sample the audio. I could make it more complicated. Oh, Tuco, you still like this, huh? So this old project that kind of went defunct, well, it didn't entirely go defunct. So as I was saying, there was kind of a small version and a large version of this project, as a lot of my older projects especially did. The small version, the way it started out was basically it had always been kind of a side hobby of, I had a college roommate, I guess, and, he kind of liked building kind of an entertainment system with different, bits of, game console stuff, especially retro stuff. And he had this kind of game console setup, which I guess would be pretty typical for a lot of people now. And anyway, it was this thing that I kind of enjoyed building with him at one point. Duco, are you done, or are you just waiting? So I got interested in some automation aspects of this, and we were originally using some existing open source platform. I think we were using MythTV back when it was really young, or something along those lines. But I got really into the idea of making my own hardware to go along with this. So at first it was just something simple. We needed a remote control receiver, and there wasn't really a good cheap option that I was aware of at the time. So I figured, hey, this is a good opportunity to to kind of synergize this with something else I was interested in at the time, and to learn how to make my own little USB infrared receiver. And so this was probably, I think this was 2002, because this was, 2003, something around there. Anyway, early 2000s. And I was interested in building stuff with USB, but USB was still not super easy to use, and basically the form that I encountered this stuff in was a series of microcontrollers made by PIC, the PIC 16C 745 and 765, which were really the same die, just bonded out with different numbers of pins. And this chip was really the first time I'd seen a USB controller that a device controller that I had some degree of access to. It was a really messy sort of environment. The options at that point were either to program it in assembly, which I was actually pretty used to. I'd done a bunch of PIC assembly at that point, so that wasn't a big deal. Or to use some expensive C compiler. I think at the time the compiler that all of their official code used was way out of my price range. So I ended up using the assembly language version of everything, and they'd provided assembly language versions of all the example code, but it would later turn out to be pretty buggy, and I ended up having to hack around quite a bit just to get it to do what I wanted. But that was my introduction to USB. And so the Media infra-widget 6000 was this thing that really was just an infrared transmit and receive device. And it had one of those little infrared receiver boxes like you would find inside any sort of television or VCR equipment. And that little box did the demodulation for you. It would, if a lot of you have probably seen traces of remote controls on an oscilloscope, but basically just imagine a train of pulses where some manufacturer-defined protocol based on the width and spacing of the pulses defines your button code. But it's pretty universal that the pulses themselves are all modulated at 38 kilohertz or so. And there are really commodified little units that include a pretty sensitive photodiode amplifier, as well as a bandpass filter that just grabs that particular modulated frequency. So I use one of those, but then I have this PIC microcontroller doing... Did Tuco put the bowl in his food bowl? I can't tell if he put it in his bowl or just next to it. This cat is so weird. His bowl is over there next to the restroom. So in the original Media infra-widget 6000, it was the little kind of, this thing that was about the size of a deck of cards that had infrared transmitter LEDs and one of these little demodulator receiver devices. And it had firmware that would just interrupt every time there was an edge on that demodulated signal, and it would use a timer to time the interval between those edges. Then it would buffer up those intervals, and as you read the data back over USB, what you got was this kind of FIFO buffered stream of timed intervals between pulse edges. And then there was software on the PC side that was actually responsible for using that to recognize different remote control codes. which is, kind of how it made sense to do it at the time, I guess. There was an existing system I was trying to be compatible with called LIRC, or the Linux Infrared Control subsystem, which I think is still the thing that you use for this, although it's probably more common in a lot of ways. I don't know, a lot of things nowadays would just do the decoding on a microcontroller and then send back, like, human interface device key presses, like emulating a keyboard. But LIRC was used pretty commonly in the days when you would build, you would just like attach this thing to your parallel port or your serial port, and then do the demodulation using one of those little doodads, but then do all the other detection, and including the timing in software in the kernel, for example. So I wanted to use basically that infrastructure, but attach it over USB, because I was kind of a fledgling USB fan at the time. So that started out as like a little puck thing, and then the project grew, and I wanted it to also have an output component. So, and that could have been a separate device, but I had this idea that people are going to want to point the remote at the thing that seems to have the most obvious user interface. So I figured the thing with the big vacuum fluorescent display should also have the remote receiver. So that's why the thing that was originally kind of an infrared receive transmitter, pulse timer kind of project, it also kind of grew a serial port. And so it was this super weird thing where the VFD was basically just a serial display. And I could have, even at the time, put a USB hub in this thing and had my IR thing and then also a USB to serial thing. But I guess at the time that seemed silly and wasteful at the time. And so instead I had this extension of the firmware that also gave it a serial port, so that in addition to transmitting infrared codes and receiving infrared codes, I think I also added some LEDs, but then you could send data at, I think it was something like 9600 or 19200 baud to this little this little vacuum fluorescent display, which would then do all of its own driving internally. So pretty weird choice, I guess, but it helped me learn a bunch of things, and that's largely why it's not especially useful to me at the time. I have this pretty nice looking vacuum fluorescent display on this thing, but so there's the front panel. Let's see, can we count these? 4, 8, yeah, so that's 20. 20 by 2 20 by 2 VFD. I'm not used to saying VFD. It's been so long. And yeah, this is kind of the front metal grill, because nowadays, if you buy one of these, it's usually just in a single chip, but I think this is one of the earlier ones where the photodiode was on the front, but then there's a little circuit board that had a little epoxy blob amplifier chip, and so then they bothered screening the whole thing in metal to keep the electrical noise low. The other weird anachronism about this is from the age of really, really early USB. Because I designed this with stuff that was relatively hobbyist accessible in 2003, which is still when a lot of people, were just getting USB ports on their computers. So, you'll notice it has both an IEC style power input jack and USB with a captive cable. This was me following the USB spec really closely. Because the VFD drew a little over 500 milliamps, so I didn't want to burn out anybody's USB port. And the I think the VFD plus the infrared transmitter especially would have drawn more than that, because I think the IR was maybe 100 milliamps or so on its own. The IR transmitter is external. This RCA jack leads to just a little IR doodad, or a Y cable with a bunch of IR LEDs, so that you can transmit control codes to, your Laserdisc player or whatever. What did we actually use this for? I think this was mostly for the television, because we had. So there's another project which I'll probably briefly look at because it's in the repository next to this one. The other project was the. What was it called? The UV switch, the USB video switch. I had to give it a weird name. It wasn't actually ultraviolet. But yeah, that was a kind of a companion project to this eventually, where it was a video, like a matrix switch. Yeah, I don't even remember how many outputs. It was like 8 inputs. It was like a video crossbar or something with like 8 inputs and 3 outputs or something like that. I built it around a bunch of discrete analog multiplexer chips. It was a really weird design. Hey, Tuco. I think I messed up something about the common mode range too, because I didn't really understand much about analog when I designed that. Anyway, yeah, so this had some weird siblings. And so because the power consumption of the IR LEDs running at these, high current pulse currents, plus the, if you're not familiar with vacuum fluorescent displays, sorry. In case you're not familiar with vacuum fluorescent displays, there are plenty of other YouTube channels that have, really in-depth information on them. But they basically involve both a heater and high voltage, so you should expect them to take a lot more current than a similar LCD. In this case, I think the total current on the VFD is something like 5 volts at half an amp. So it's probably something that nowadays in 2017 I'd be pretty comfortable with sticking on a USB port, at least in something that's going into, like a modern computer and not a Raspberry Pi. Especially like a USB hub, or especially if I had a nice PTC fuse or something. But yeah, in this design I made a weird decision, and that's partly why this is big, but there's still a lot of empty space in here. The VFD is pretty narrow, and then this is the power supply board on the back. Well, let's get Tuco back in frame, and then let's take this thing apart. So, what they say on the EVA blog. I mean, so I would actually, I would actually like to turn it on, but it wouldn't really do anything. You'd probably just see the cursor blink. I guess we could do that. I don't really necessarily want to hook it up though, because it's really boring, and we'll see the VFD running in a bit. In fact, these screws aren't even that tight. I was about to get up and grab a hex driver, but these are just finger tight. Let me also make sure that we don't run out of camera right where this gets interesting. Tuco's sitting in the shadows. He's a shadow cat. So yeah, be gentle on me. I learned a lot when I was building this. But you should be gentle on everyone. I mean, I don't like it when people are really snobby about knowledge. It's not how you learn stuff. Oh yeah, I skipped over something else about the USB spec. So yeah, when I was building this, I was trying to be very USB spec compliant, because, I just read this giant document. I wanted to put that to some use. So in addition to being very conservative with the power, so I think this powers the microcontroller, but the IR and the VFD are definitely running off of this. So I think I stayed under 100 milliamps with this. It's also a low-speed USB, because these chips only did low speed. If you're not familiar with USB speeds, it's a little bit confusing for people who haven't been indoctrinated into the particular cult of the USB spec, because a lot of people hear something like high speed and they just assume, oh, it just means it's fast. But USB high speed is actually kind of slow by today's standards. So with USB, it starts with low speed, which is the 1.5 megabit standard. That was what they came out with at the very beginning of USB to complement their 12 megabit full speed standard. And the logic behind that was 12 megabits is what they actually wanted, because that's what most kind of higher end peripherals could handle. That's what you needed for stuff like serial ports and like flash drives of the era. But it was also relatively expensive to actually implement the silicon for 12 megabit transceivers at the time, and relatively power hungry. So the 1.5 megabit standard was actually like everything bending over backwards to support these very slow transceivers and very slow devices. And in fact, if you look at the way hubs work in USB 1.1 with USB with full speed and low speed, if a hub is basically the hub has to switch the entire upstream bus temporarily into low speed mode. So when you plug a low speed device into a full speed hub, you're actually, during the duration of that low speed packet, slowing down the entire bus. So, which, isn't necessarily all the USB ports on your computer, it's just that particular full speed bus is slowed down. Anyway, USB is full of weird gotchas like that. So at the time, I was still in that really low-end tier of silicon that only had access to that 1.5 megabit speed. So because they were really bending over backwards to support these really low-end devices, there are some significant protocol differences between the low-speed and the full-speed devices. I should actually make sure that I talk about all the speeds and I don't get ahead of myself. So speeds. Low speed was 1.5 megabits, full speed 12 megabits, and full because that was from the original USB spec. When USB 2.0 came out, that's what added the high speed spec. So for 480, hey Tuco. So USB high speed is 480 megabits per second, and that was the maximum speed all the way until USB 3 came along with their 5 gigabit and then later 10 gigabit modes. And so the 480 megabit is also the fastest you'll see on the original twisted pairs, because USB 3 added totally new sets of wiring for the high speed, or super speed, because of course they needed a new name. So high speed is 480, super speed is 5 gigabits, and I haven't even read the 10 gigabit spec, so somebody will probably have to mention in the comments what they named that, because I haven't gotten around to catching up with USB, what was that, 3.2? Yeah, USB-C is leaving me in the dust. I haven't worked on USB really seriously since the dawn of USB 3. But I'm sure that'll change at some point. So with this project, I had access to the full glory of low-speed USB with 1.5 megabits, which actually had a lot of restrictions. It didn't have access to the normal USB time-based start-a-frame packets that full-speed and later devices get every millisecond or every eighth of a millisecond for synchronization. So, the packets just kind of come like in this little stream, like as they're needed. It only supports a couple of the transaction types. So, if you've done any USB device programming, you've probably seen like bulk transfers, which kind of act like you're reading or writing a file or reading or writing a pipe. Or there's fancy stuff like isochronous transfers, which are used to transfer data at a well-defined rate for audio or video. And then there's control, which is ubiquitous of all USB devices, because that's what actually is used for setting up the device at a protocol level, and it's also available for the device to use in its own ways. And then interrupt is kind of usually a little bit weird because it looks a little bit like bulk in that it's dealing with streams of packets, but it also has this aspect of isochronous to it where there's this reserved bandwidth set aside for polling the device periodically. So it's sort of like bulk in that you can transmit, bits of data back and forth and they kind of get there when they get there, except that there's also this higher priority at play. So anything that's interrupt is always transmitted before the bulk. It always gets a chance to transmit before bulk gets a chance to transmit. And then it has some other weird limitations as far as bandwidth, whereas bulk will just continue to try to transmit until it gets a knack, during that one frame, up to a particular limit in the host controller. Hey, Tuco. Interrupt transfers have that really strict bandwidth limit, so that's why, if you're working with a device that has this low-speed USB limitation, it's not just the 1.5 megabit line rate that you're dealing with, but the protocol then will often limit your practical data rate to something more like, 8 to 16 kilobytes a second or something more in that range, because at that point it's more like you're getting a constant stream of packets at a rate that's kind of at the operating system's discretion, but if you're lucky down to a millisecond, and then the bandwidth you get is that rate that you ended up with the bandwidth is that rate that you ended up with combined with the packet size that you're allowed by the hardware. And if I remember right, this device has very little hardware buffers. Like, I think it can only handle 8-byte packets or something absurd like that, but it's probably a little bit bigger than that. So anyway, that's another reason why this couldn't just act like a regular USB serial device. It had to kind of shoehorn, both this FIFO of infrared data and this auxiliary serial port into this kind of weird, this protocol that was really restricted both by the hardware on this chip and by the actual USB spec this was trying to follow. So because it was using low speed, in addition to all the weird protocol restrictions, low speed does not allow you to use connectors on the device end, which is, I don't know if anybody follows this for reals, but like a very common low speed devices still are mice and keyboards, especially mice and keyboards that don't have like any fancy features. And you'll notice they often have, they don't have like a socket on them, they have the cable wired directly in. And that's actually a requirement of the USB spec, that if you're using the low speed protocol, it has different electrical impedance specifications for the wire, so you can't guarantee that the low speed kind of cheapo transceiver is going to actually drive whatever random cable you attach. So to meet the spec, you actually have to have a cable that's no longer than a certain length, and I think there are different impedance or different different requirements for how strictly controlled the cable has to be for low-speed devices. So anyway, that was a futile attempt to be following the spec. I'm sure it didn't actually matter that much. So let's finally open this thing up. There we go. So this was just a standard chassis. Back before we all had 3D printing. Oh, Tuco, I'm so sorry. I just bonked Tuco with this case. I don't think he minded much. Yeah, so this case, I think I got this at some local electronics store or something, and then painstakingly cut everything out with the Dremel and didn't really do a super straight job of it, but it worked all right for my needs. So let's take a closer look at this thing. So here's the power jack grounded to the chassis. Soldered. Probably should have heat shrunk some of this. I don't know why the hot has a heat shrink and not the neutral. That's kind of weird. Maybe I lost one of these connectors at some point. That's weird. Anyway, and I think this was just a random power supply from a surplus shop. What is that rated at? 5 volts, 1 amp. Which, it's like really weird to have a USB device with its own 5 volt 1 amp power supply, but that's what I did. So, front side. Now I can start to see the vintage stuff. So, there's our processor. So this is the ultraviolet EEPROM style microprocessor, back before flash memory was common. And actually, I heard from somebody at Microchip mention that this is one of the last processors that they made in the windowed non-flash memory ultraviolet array style. Because I guess it was also like the first processor with USB, so weird little overlap there. You can see I recycled some of these connectors from like old PC case stuff. So yeah, there's a little sticker on there to keep light from erasing the chip and also label it with a revision number. That's the crystal frequency, 6 megahertz. Little 8 pico load capacitors. And then over here we got some transistorage. So this is, I think this is a Darlington style power transistor. That's a tip 31. I forget whether it's Darlington or not. It might just be regular NPN, but we can look that up. Some variety of power transistor of the bipolar type. And then a couple of smaller power transistors, I guess. I do actually have a schematic for this, so we can take a look at that and compare it with this. But yeah, this was a etch-at-home circuit board. We can take a look at the other side and get a closer look at that. And it's a little precarious here. It's actually only bolted down with one screw. I don't know why, or no, I guess it's got 2 screws. Ooh, that's a better view. Okay, so you can see the VFD had this connector here. Oh, that's what was sketchy. I guess it was originally a shrouded pin header designed for like a ribbon cable it plugs in, but the connector I had was a little bit too big around the edges, so I guess I had to trim off the shroud with cutters. It's a little unseemly, but it'll do. I mean, the actual VFD it's this glass vacuum tube, and literally it's a vacuum tube. It has, you know, a vacuum, well, partial vacuum and a heater, and let's see, nice seals too. And then you can see the hot nut, which doesn't look bad from the front. But this is holding the LEDs in place, and these were, if I remember right, really ugly non-diffuse LEDs, so they're kind of eye-pokingly bright, in fact, so I probably should have sanded these before putting them in. So I think some of the transistors are for turning the LEDs on and off. I don't know. Actually, the LED should be able to... So the PIC, I think, can drive like 20 milliamps on its own, so I think the LED should be fine. I think the transistors are probably... There's probably one to turn on and off the VFD. Since the VFD doesn't have its own power control, and I wanted to have the firmware be able to turn it off to save its lifetime, so I have a transistor to do that. And I guess I have 3 more. So that would probably be one for the IR transmitter. And maybe I did use one for each LED. I guess we'll have to take a look at the schematic and or trace the circuit. So, oh yeah, on this side you can see the receiver unit. Oh, and you can get a view of the high voltage power supply section on the VFD. So, oh yeah, you're in servo AF mode. This was a really nice VFD unit. Like, I was surprised to see these going for $20 each on Surplus at the time. So yeah, it looks like we've got all the basic parts of a switching, like a flyback converter or something similar over here. I haven't actually traced out this circuit, but transistor, capacitors. This one might be like an input filtering inductor, but that's like their main switching transformer. And then this is a bank of VFD driver chips, which we might even be able to find data sheets for. Alright, let's look at the schematic actually before we go any further. Hey, cats. Alright. Oh, I can turn off some of these overlays. Okay, yeah. So, the small project and the large project. The small project was the Media infra-widget 6000. The big project was Wasabi, which is what that kind of larger home theater PC software hardware thing was going to be. I think we had some kind of grand vision at the time of maybe starting a company to build set-top boxes around open source software, but we wanted to see if we just liked building set-top box software first, so we just tried building this as a hobby project, and it was alright, but you know, it didn't really take off. One of my favorite remnants from this project was actually some of the artwork I did for it. I ended up doing this whole series of, oh, what is this? Oh, this is an old friend, Jet Cow. That used to be the Jetstream copy on write database, which of course needed a logo. That's not a real logo. I think the actual logo was like a swirly particle system, so that was just the text for it. But anyway, I did this whole series of icons for it that were in this kind of like, you know, like sort of candy style. I forget what that says. Oh, I think that says wasabi. I think that was part of the menu. Mostly it was like video game system logos and stuff. I think my favorite one was the PlayStation logo. Oh, I also like the GameCube. Oh, not that one. Ugh, that one wasn't any good. PlayStation. Yeah, I like how that one came out. Anyway, lots of junk here. What else? Devices is where all the hardware ended up. So yeah, this project was sprawling, man. We never actually managed to make a working set-top box. But, so MI6K was that infrared thing that we're going to be taking apart. Oh, here's Tuco. Oh geez, Tuco's changing the name of the video again. Let me, maybe... Oh, Tuco. I just want to hit backspace, cat. Sorry. I just don't want Tuco to insert a bunch of unnecessary punctuation like he seems to enjoy. Okay, maybe I'll just lock this and then put it down, assuming he'll come back. Hey, Tuke, I didn't mean to scare you off. Jeez. Oh man, and yeah, this was a big thing all of it its own. So anyway, what even was this? Oh yeah, the GameCube hub. This was a thing where you could plug 4 GameCube controllers into it, and then it attached over USB. But then, I think for some obscure reason it wasn't a human interface device. How did that even work? So also, all of this stuff was written in assembly. As I mentioned, I didn't have access to their fancy C compiler, and I was kind of used to assembly anyway, so I just went with it. And it's a lot of what you're seeing here is the boilerplate code from Microchip. So a lot of what I didn't like about this is that they didn't really make it easy to use their code as a library. You basically had to take this kind of sprawling thing and then hack it up to make it do what you wanted. It was really bad. Oh, maybe I had a separate... I guess I did a lot of this stuff in macro files that were included into the firmware. This is what actually talks to the GameCube, or GameCube controllers. Yeah, I don't know why this wasn't hid. So there's that, there's Cube 64. Ah, this was, I don't even know why this is in the same file. This was just an adapter that went from GameCube to N64. So this is only tangentially related. I guess it used some of the same code. Yeah, so I don't know. This was like my roommate had all these retro game consoles, and I had this crazy idea to have basically a controller crossbar switch that would let you use any controller with any system and remap stuff. And it was weird. It was basically an excuse to make an FPGA thing that emulated a bunch of controllers. Invalid. Oh, that's probably a project file. Some of the Xilinx software used PDF as a project file format, which was really weird. Oh, yeah. This was also like really early days USB. I used this chip called the TUSB 3210, which was designed as a USB serial adapter, but I wrote my own firmware for it using the venerable SDCC, which is like the most broken compiler you'll ever write code for. Alright, so yeah, okay, let's go inside MI6K. Tuco, what are you doing to that? Okay, so among the many reasons this thing is inconvenient to use in 2017, there wasn't really a user mode, like libUSB kind of thing at the time, so the way the way I accomplished USB communication was to write a kernel mode driver, of course. So as you can see here, I wrote all this stuff 13 years ago, and then 2 years later updated it to work with Linux 2.6.17. So that's the state that it's in. And so this is actually just something that back in the day it would have been sensible to load into the kernel, and this is where it actually got, like, if you had this, it was convenient to use because then you got a character device you could write to that would write to the VFD, and it would emulate the LIRC kernel mode interface for the infrared transmitter and receiver, so it was actually convenient if you could make this kernel mode driver work. But if you were just working with the USB protocol, it was super annoying. But, I mean, these drivers are not large, but they're really easy to get wrong, and they always change from kernel version to kernel version because, compatibility isn't really a priority in Linux. They just change stuff when they feel like it. I had device I/O controls for power management. So that's actually one thing I haven't decided if I want to keep is, in this, as I mentioned, there's a transistor that lets it turn on and off the VFD. I don't know if I care about that. I mean, it will probably save tube lifetime if I can do that, but there might be other ways to do that. What I might do is even, one option is to use a USB to serial converter, but have a really little microcontroller just do power management, and it'll just turn off the power if it doesn't see serial data for some amount of time, which seems pretty sensible. Which is probably what I would have done in the first place if I hadn't already had a reason to make this thing so custom. So there's all of this stuff, which I learned a lot from writing it, but it turned into a maintenance liability really quickly. I wrote, LCD proc, which is also something that I guess people used back in the day. That was like probably still is an open source thing you can use to attach like screens to your Linux machine and make it display stuff. Man, I guess there probably is already a way to write plugins for this whole framework, but I don't want to use a framework. I just want to write a Python script that monitors the stuff I care about and writes it directly to the display. We might be able to learn how to control the display from this, though. Because, for example, I don't know how easy it'll be to find a datasheet for this display, but we can copy stuff like this. We know about the home. We might even be able to figure out how to set custom characters, which is something I might want to do. Oh yeah. So this is something we can totally just copy to figure out how to learn, or to figure out how to use the serial protocol. Yeah, so it looks like there's a header, there's a command 18, and then this identifies what custom character we're setting. It looks like there are 8 of them, and then we just write the binary data for that character. So that could be fun. Lots of stuff to steal from. Oh, I guess I had some stuff that didn't use... This might be easier to adapt, actually. I had a Python thing. Oh, how does this work? Oh, this talks to the kernel module. Of course, it just doesn't use LCD proc. So it's using those I/O controls to tell the kernel to tell the USB over control requests to turn the power on and off. This write VFD... How does that work? Oh, Century VFD, I guess that's the brand name. There's probably, I mean, it's probably pretty easy to find a match to these particular commands, but this might also just be a library we can use. Ooh. Oh, neat. This would have been hard to figure out. It's nice having already written code to do stuff like this. Present me thanks past me for some of the things that they did. Oh, so the VFD has its own brightness control. I remember it not being super sensitive. I mean, I think at the time I was concerned with saving the life of the tube by turning off the heater, as well as keeping the display dark sometimes when I'm not using it. I don't actually know how much the heater contributes to the tube aging, but I figured it was probably a good idea to turn it off. But maybe thermal cycling isn't so good for it either, you know. So I can probably strip this down and replace some of this with just a serial port, like PySerial, and then use this to talk to the VFD, or maybe even find somebody's existing library that already just talks to this particular VFD. Let's see how this gets through to the kernel. Yeah, that's just writing it to the character device. What does the firmware for this look like? So I don't think there is a separate new file. There's just, oh man, I had this weird habit at the time of writing the end at the end of all my files. Like, I was worried about the code just kind of dripping off the end if I didn't have a barrier to hold it up or something. Yeah, this stuff was super weird. It's like, we're gonna give you all this code and you just deal with the licensing. So even though this was a pretty early device, the hardware does a lot more than just a serial port. The hardware is actually going to be responsible for handling a particular layer of the USB protocol where it's looking at the first little bit of each packet, the token, and figuring out, which buffer it pertains to. Is it reading? Is it writing? It handles flow control. And that's all handled in hardware here. And so actually, if you look at this, it's fairly similar to how a lot of more recent USB device controllers work, because it's really all just based on the USB spec. So the hardware has a collection of buffers that are in dual port SRAM, and the buffers can either be owned by the hardware or by your device, and so you can double buffer them and have the firmware be processing one buffer while the hardware is processing another buffer. Everything's memory mapped. It's also banked. I hate banked memory. PIC assembly was really fun when the processors were small enough that I didn't really have to worry about bank selection. This brings back some weird memories. So yeah, macros for some of the USB. All of that I think is just the microchip boilerplate code. Chapter 9 refers to the part of the USB spec that actually lists out all the things that you can tell a USB device to do. So that's mostly where the actual functionality of a device gets stuck in the implementation. So this looks like I added some external functions. VFD send by, IR send by, IR flush, that I would expect to see this calling. This is like USB power management stuff that I don't know if it actually ever worked. Man, all this old school USB hardware. So these are registers that control the status of the various sets of buffers that the hardware owns, or that the hardware can own. And different hardware-assisted error conditions. So far this is all boilerplate. Descriptors, this is where you might have seen these feature in the earlier glitching video. This is where you ask a USB device to identify itself and it returns a little bit of memory. So this device does the same thing. cat configurations, set interface. Okay, now it's actually starting to get to... So all of that was just stuff that is in the USB spec. Here you have vendor-specific calls. So here I'm just testing which one is which, and break it out to different functions. This is basically a very crude switch statement. Yeah, oh, and this was weird. This was super hacky, because I was having trouble with the USB serial engine and getting it to handle data packets correctly. So I just stuffed 4 bytes into the available fields in the header for the control request. And so you write to the VFD 4 bytes at a time with control requests. It was really slow. But the serial port was also slow, so it didn't really matter. And for IR, there's also a control request that stuffs things into a buffer to go out later. Power management, LEDs. The LEDs just set the... This is like set analog in Arduino speak. This is just changing the pulse width modulation duty cycle that would control the LED brightness. So this is just aligning the value to be at the right... because the original value coming in over USB, I think, was 16-bit, and I wanted to align it to be 10-bit or something like that. I think most of it I tried to keep in this file. What else is there? There's also descriptors, which I think this is mostly strings. Yeah, these are data tables. The way you do data tables on this processor is with like a big field of return instructions that you jump into, because it's actually pretty efficient because the processor has 12-bit memory. So you're going to be using 4 of those bits, or wasting 4 of those bits anyway if you're storing bytes for the most part. Weird times. USB main. Still lots of boilerplate. This is the actual IR stuff. I was using this timer interrupt to actually time the IR. And it stores it in a circular buffer. Yeah. Oh, I guess I can end up storing either... I guess this is an overflow, and this one is an edge detection. And so the overflow is write an overflow into the buffer, and the edge detection is write an edge into the buffer. Yeah. Oh yeah, here's the VFD. VFD send byte. And... yeah, this is pretty old. It's bringing back a lot of memories. Anyway, so yeah, this starts out by just writing it directly into the hardware UART, and then we're... I like this instruction. This is bit test on a file register, skip if set, and so that's how it does conditionals. So it tests a bit, and then either skips over this goto or not. Really cute little processor. I think this is from the generation of PICs where they only had something like 33 instructions. So it was a really fun chip to learn assembly on. Alright, let's take a quick look at the schematic and then see if we can match that up to the hardware. Oh, I wanted that still. There's so much stuff here. Oh yeah, and then here's 2 versions of it. So the portable version was just the IR. Portable media infra-widget 6000. So we had kind of all the boilerplate stuff, the decoupling and the crystal, some LEDs. The IR detector was just the thing that you plugged in. This was... I wonder why I did it that way. I guess I wanted the... Oh, yeah. I guess I wanted the the LED to have its ground common rather than be pulling the LED's cathode to ground when I'm transmitting. So I had the LED, because here the LED is self-contained, but in the other version the LED is separate. So I think I wanted to be switching on the high side of the LED rather than on the low side, so that the low side could just be grounded. So here I'm using a PNP transistor, which acts like a current amplifier. So it's amplifying the small current that goes through this this resistor. So it amplifies the small current that goes through R10 when pin RB6 goes low, and then that small current flowing through here ends up in causing, through the gain of this transistor Q3, allows a much larger current to flow through the 5-volt supply into this diode D3 here. So we should see pretty much the same thing on the larger version with some additions. This is the set-top box. It's so little. Okay. So yeah, same IR circuit over here with a 10 ohm resistor in series, I think, just to keep people's LEDs from burning out with the high current pulses, but I don't know if that was actually necessary, because this will also end up acting to limit the current as well. I guess that wasn't a Darlington transistor, so I guess I made my own Darlington pair. So I have, and this time I'm switching the low side of the VFD. So the VFD's ground is normally floating, and then I ground it with this big NPN transistor. And then this, another 2N3904. So this guy, oh, this is weird. I probably just built this out of whatever parts I had handy. Oh, I see. And so this transistor, I think I was using that as an inverter. Because I think this, that might actually complicate things. So if this VFD is expecting kind of classic high voltage RS-232 flavored serial, then I think it worked on 5-volt serial, like TTL style serial, but besides the voltage difference, there's also a polarity difference. So I think I was using this transistor just to flip the polarity, since that wasn't easy to do in hardware. But actually, if this is looking for just an old school RS-232 signal, then I could just give it that. I think I have our serial adapters that we could use that would accomplish that, so that might just be another easy fix. Yeah, and then up here, same circuit. We just have basic old microcontroller, old school microcontroller. Anything else interesting in this directory? Oh yeah, well I fabbed the PCB. What software did I even do this in? Is this Eagle? I think this is Eagle. No, that's not what I wanted. Anyway, I don't really want to open the board right now. I have PDFs. Yeah, so that was my layout view. Let's keep that handy. Where is the cat? Oh. Maybe he's just decided not to be sitting on the computer. Maybe I can unlock it and check chat. I know I've been neglecting you on the chat, sorry. Alright, so there's the board. And then this is what I actually printed. So this was a one-sided layout, right? Yeah. I think I remember using somebody's laser printer, like borrowing one at school or something. Yeah. I looked at this at first and I didn't even notice it was single-sided because like it's just a circuit board. But yeah, that must have been fun. And then this matches the actual VFD connector. So we should take this apart, and then I'm also going to look for signs of, I'd like to see if we can just find a data sheet for this VFD to just get an idea of what it's expecting. Because maybe we just throw, some existing RS-232 adapter at it and we're done. Ooh, there's jumpers to set baud rate. And there's a self-test mode. Let's go back to the camera. I'm gonna check the chat too. No more movies. Oh, I noticed a comment about the 13 years ago on GitHub, and so actually that was not originally on GitHub. That was I used to keep pretty much everything I worked on in one giant Subversion repository. I forget whether it started out as Subversion or whether it was originally CVS. It was probably always Subversion. But I called it NaviMisc because the server it ran on was called Navi after the computers in the anime serial experiments lane. Because that was the particular kind of nerd I was at the time. And so, of course, it became this sprawling monster of a repository because it was so relatively annoying to actually create new repositories for each individual project. Alright, let's dig into this thing. It's still tempting to turn it on, but we gotta stick with taking it apart, because, that decision's been made for us. Alright. So, let's just try to get this whole front assembly out. I mean, yeah, it's tempting to save this hardware, but probably not for this project. I mean, of course the hardware is nice, but the way I envision actually mounting this is instead of a giant set-top box thing, I kind of want something that I can magnet onto one of my light poles. So it would just have like a U shape with magnets embedded inside it that would hold on there, hopefully very snugly. But I imagine instead of using the screw holes, I would probably hold on to this by having a plastic slot that's 3D printed that the circuit board fits into. Oh, I might actually get a driver for this because these screws are kind of tight. I think we're going to have to do a teardown of the microcontroller too. Oh, are these metric? These aren't metric. We've been down this road. All of my screwdrivers are metric. I guess this was before I had seen the light and switched to, I mean, it's not like all my screwdrivers are metric, but all my hex drivers apparently are. Maybe this Torx is close enough. Man, these screws are terrible. Maybe I don't care as much about saving them. when the flat-bladed screwdriver is almost, but not quite, the right size. Oh. Have anything that'll fit these nuts, maybe? I'm just gonna grab them with pliers. It's not gonna be elegant, but none of these are even close. How is it that they're all so completely too big or so completely too small? It's almost like this is designed for a completely different measurement system than the one I'm using. Oh, is this one gonna be close enough? Oh, that's really shabby. But let's try it. Missing part of this screwdriver. This new Tuco cam has manual focus, which means that it's always my fault. Is that in zoomed or not zoomed? I think that's wide angle. No. I guess I was overestimating this thing's zoom capabilities. I think that's all we get from all the way over here. This is completely not the right screwdriver, but it's working. I couldn't tell whether that was the train outside or the wires in the VFD singing after I hit the case. I think the wires are making noise. I'm gonna have to try holding that up to the mic. That's the air compressor. I should turn that off. I don't think I need it anymore. be slightly less gentle with this whole contraption after getting the VFD out. Maybe I'll turn some of these like little random side project things that, you know, are like kind of interesting to document but don't necessarily need much explanation. Like I could turn them into more kind of weird music videos like that Boldport Engineer Superhero kit that I made. I don't know, did people like that? I can't tell. It was like really different from the other videos, but I enjoyed experimenting with something different. I mean, I know some people liked it. The Adafruit folks seemed to like it, and I mean, I like it, so I would keep doing more. Alright. Let's mix it up with different angles here. No. No. That's not. I might have to get a wrench for this. Just a second. Just minor equipment problems. And a big wrench for this one. Camera arm is really awesome when it works, and kind of frustrating when it misbehaves. Alright. So it has this. There's really no way to stand that without the. Yeah. So, I need to make sure I don't get grease all over my clothes when I work on this. So there are two ball bearings on this thing. There's one set on top, which is just like a thrust bearing. The races are uniform. Just got a bunch of balls there that can handle a lot of force this way, while simultaneously turning so that you can actually adjust it while it's tight. And then on the bottom, there's a totally different contraption that's also full of steel balls. And this thing is super nerve-wracking because it always just feels like it's gonna just spill balls everywhere and I'm gonna lose them forever. Okay. So then this side has this crazy non-uniform bearing race, which is what makes the whole thing work. How close can I focus? That's nowhere close. Yeah, you can kind of see it there. So it's like there are 3 separate grooves that are, they each go from being very shallow to pretty deep. And then there's another piece down here. Oh. Two of the balls just fell out onto this chem wipe, but this is basically the other piece. Focus. So yeah, there's some grease in there, and 1 ball bearing, and there should be 2 more. So I understand that it could be doing this because of some gunge in here. I guess I see some gunge in here. I guess I just need to clean this again. Maybe there is some freshly liberated gunge that managed to stick in just the wrong spot. So I'm trying to just get whatever that is out of there. And then maybe I should really give this thing a thorough cleaning with like simple green or something and then re-oil it. But for now, I'm just going to put it back together because it's still got plenty of grease in there. And we can get on with the show. As fun as it is debugging camera equipment, there's so many other things I could be debugging. This thing is a real pain to line up. Okay. I think, let's test that. Let's try slightly more tension. I don't know. Maybe it just didn't have enough tension to hold fully. Let's give it a little bit more just in case. That's solid. For now. Okay, now I try to remember which side of this goes where, if it matters. I don't think it does. I guess this side goes on the base, because that seems to be what you want to lever against. Hey, train. Okay. Ah, such a relief when I turn it and it doesn't make that horrible noise. And it actually stays put. Great, okay. Let's try to make sure things are appropriately degreased. Okay, great. Thanks for bearing with me as I fixed my camera equipment. Alright, back to this thing. So I was just taking these screws the rest of the way out. Let's go ahead and get a fresh file. I'm gonna have to make sure to keep these bolts somewhere where I know they're not metric. I'm sure the spacers are fine. This is not really threaded, it's just tight. I feel like I'm neglecting my cat photography duties. Oh. Okay, I think that's the best I'm gonna get, which is still much better than the old webcam was giving me. Cat. Okay, I think that's all the screw. Oh, bottom screw still. That one's being annoying. Looking at the monitor and not at the screw. I think these bolts are going to be a little bit the wrong size for the VFD. I think there might be some like foam sealant I added. think there's like foam weather sealant, like what you'd use for doors around here. Trying to ascertain if that's the only thing, and if so, how best to pry it off. Did not realize I was gluing the VFD to this case with foam. Oh. I can take off the circuit board first. So, use tweezers just so my fat fingers aren't in the frame. Pliers. So that's the USB cable. This is like the kind you'd find going to a motherboard. Looks like I spliced a regular USB cable onto a 5-pin header. And then there's one of these little push-through strain reliefs. You can get a proper spanner for that. I think a little vice grip is what I want. Nope. Did I solder this? Oh, it does fit. Great. Well, I guess that can just be a cable. Exist in free space as a cable on its own. Now we've got this little thing, which might also be a nice little... I don't know if I can get this out of the panel without unsoldering it, though. Oops. Yeah, I definitely soldered that in place. The other end was not coming off easily. Alright, I'm just gonna cut this. Might want to reuse this little connector though. I mean, I don't know, the plating seems like it's seen better days. Right. I guess while we're taking stuff off the back, I wanted to take the VFD off, but it's proving to be complicated, so I might do the simpler things first. Oh, I guess I never mentioned what the camera arm was. It's Manfrotto Magic Arm. It's been pretty awesome, except for that when it, gets all out of whack and doesn't actually want to latch. But I don't know how heavy duty they're intended to be. I use mine pretty much constantly, so it might be in need of some replacement parts at this point. I don't know what this was for. I guess maybe some light was shining through around the power jack. I don't know. Certainly wasn't keeping the electrons in. Definitely Dremel cut. So then this is held in with a few more of the same. I remember these power supplies being... So I think I got the VFD from BG Micro. I think I got the power supply either from there or from All Electronics Corp. And they're definitely still around. They still have awesome stuff. Yeah, definitely check out All Electronics. I've been a customer of theirs for a long time. Like, I remember they used to... Well, I used to get these electronics magazines, and they would have like one page of their catalog taken out as a full page ad, basically. And so you could order something cool directly out of the back of a magazine. And where by order, I mean, I would like write down the model numbers of all the parts I needed, and then like go use the telephone to call it in, and borrow somebody's credit card. But yeah. And then once you'd placed your first order, you'd get a catalog, which was super nice. And then they would just keep sending you catalogs. It's a cute little power supply. It's, oh, there's the optocoupler. Oh, that's such a nice little thing. So it's got feedback, it's got some good isolation. I mean, I remember these being actually pretty legit power supply modules. Really bunched together on the input, or on the, that's the secondary side. And on the primary side, fused in one of these little cylindrical packages. What is this coil here? Is that power factor correction? I don't know. If you know what that is, definitely leave a comment. I'm curious. Anyway, it's a pretty basic little power supply. So, other end of the power supply is actually... Other end of the power supply is actually wired into this board. And it comes in kind of weirdly on these two pins. Alright, power supply extracted. Alright. LEDs are just hot glued in here. We can use everyone's favorite hot glue release trick. This is 99% isopropanol. And I think this will just cause the LEDs to pop right out. Oh man, look at that. It just comes right off. Let's zoom in for the next one. It just comes right off. I think we can even take the LEDs out if we want. Might have to infiltrate some more alcohol in there. As I mentioned, these LEDs are not great, so I don't know if I'm even going to bother saving them, except that they're already on such nice little wiring harnesses. Might save the wires and throw away the LEDs. And should be able to use that same trick to get the IR doodad off. We might take a closer look at the IR doodad, since this one's so anachronistic, being like its own circuit board and everything. This is me moving things around on my desk rather than risk the camera arm again. Alright, let's just release it in that position. You can see the circuit board wiggling inside its cabinet there. There's the alcohol doing its thing. Real time. So let's take a closer look at this little module before we move on too much. This IR receiver doubles as the turbo switch. Retweet if you're old enough to remember turbo switch. Retweet if you're old enough to have written code that needs the turbo switch. Retweet if you've ever written an emulator that emulates the turbo switch. And retweet if you've ever checked whether someone else's or turbo switch emulation is psycho-accurate. Yeah, that rabbit hole goes deep. So, let's put this aside. And this stuff's already starting to come off. So I guess while we're cleaning things, we might as well clean the LEDs if we can, just because it's kind of fun. Even if I don't like these LEDs, I guess they deserve my help. Whoa, that has some grody solder. There's like a huge blob of solder on one lead, and then the other lead is heat shrink. And is this, oh, this one's even worse. This is like, oh, what idiot made this? This is like a blue heat shrink that doesn't quite actually cover. Maybe that shrunk before it was actually, like while I was soldering, maybe that shrunk. And then the other side is covered with electrical tape. That's terrible. But you know, you gotta start somewhere. Everybody does stuff like this. Oh yeah, maybe I can... Bloop. Oh yeah, that's fun. Oh, focus. Oh, very nice. Alright, let's get it off of this thing. So I think this was originally intended, I think I salvaged this off of something. I think this was pulled off of a old VCR or something like that. But it would have been circuit board mount, so if my hand is the circuit board, and it would have been facing upward. So there's probably like a circuit board in the front of your VCR that has a bunch of buttons, or like DVD player, something that has a remote. And so there would have been a circuit board here with LEDs and buttons and stuff, and this just mounted on top. This needs a little more isopropanol. Delicious. This looks like it. I don't know. This is all hot glue. I thought I might have also used some other kind of glue. Oh, I think I might have tried soldering it to the front. See that? That kind of looks like I tried soldering this to the front, which I don't think that would have worked for a number of reasons. Partly, well, mostly the case being aluminum. But let's take this shield off. I think, you know, despite this being kind of useful, it's also really archaic, and I'd rather not use an old one like this if I was using this in a project, so I think we'll just tear it down and take a look inside. Let's warm up the iron so we can take off this connector just to get it out of the way. This might be microscope time already. Try out some new camera angles, see how that works. We need these lights though. Oh, do we? I'm still not happy with the color temperature on these lights. I need to find a solution for that. Might need to clean that before we can tell what that chip is. Flop. Alright, there's some junk there. I guess I'll take some of the junk off even if I don't really need to. Well, maybe I'll find a use for this footage. I think I'm recording this from the source. See, this is also, this is why I need this project. I would be able to glance at the VFD and see which of my recorders are running. And instead it's like, oh, it's probably recording. And I'll just find out later if I don't have the footage. Or I get up and check. This case is making a decent heat sink at the moment, so maybe I won't worry too much. Maybe I can just pull those pins out and then get the solder out. I think these were originally like circuit board pins. Well, I'm going to take the case off anyway, so maybe I'll just brute force that somehow. I'm picking it up with pliers because it's probably still hot. So, just gonna do that. Whoa, this is very old school, actually. I've seen devices like this, IR receivers that have a like an epoxy blob, but this one seems like it's all like, so there's an SO8 surface mount chip, which is going to be the amplifier demodulator, and then the actual photodiode is a through-hole part. Let's just see if I can break off that shield. Maybe not. Wow, so this is on a really cheap, like FR1 single-sided sort of board. Oh, this one. Yeah, so that's the top side. Is that a model number? CMK290HB. So then that's going to be a photodiode with the epoxy transparent to IR but opaque to visible light. So that's why it looks black. But if we were looking at it with an IR camera, it would look like a clear LED. But it would be a photodiode. That's a Sanyo 2.2 microfarad cap. And then everything else is on the back side, just in that SO8 chip. Oh, a couple of passives. Resistor and a capacitor. Another capacitor. Let's see if that's just dirty or if there's just no number on it. I'm just going to take this off by metal fatigue. Ah, I got smaller conductive brushes. I'm happy about this. Oh, I see markings. Is that an op amp? Looks like a National Semiconductor logo, and if I can get that number and light just right, we should be able to read it off. I was seeing glimpses of it, but I want to get a good photo of it. 280. Is that 2800? Yeah. 2800138. I wonder if this is just an op amp. I've never seen one of these built with just like general purpose components. I've always seen them using application specific parts. This should come out as I let it dry. Nice. Alright, so let's see if we can find that on the computer. One 138 maybe? Not seeing anything super relevant so far. There's a national LM138 voltage regulator. It's not right. Not even sure which part of that is the date code. I was assuming 2800 would be the date code. Well, it does look kind of like an op amp, doesn't it? Maybe we can even just see what the circuit's like. So, yeah, those two through-hole leads there are the photodiode. So it looks like one end is going to, I assume that's the ground plane. And then the other photodiode lead is going directly into that chip. I mean, it's hard to tell if there's a trace under that. We could take off the chip. Anyway, if anybody has an idea for what this chip might be, I'm curious. Definitely leave a comment or, poke me on Twitter or something. I'm going to put this piece aside for now. Got some interesting photos of it at least. Alright, back to the corpus of this. We have a metal case with the VFD somehow miraculously stuck to it. And I want this one. And I want to take a look at this circuit board actually, so maybe while we have the microscope and light close, we could take a look at this. Let's restart this. So, there's the circuit board, home etched. I wonder if I put anything over this to keep it from oxidizing, or if I just got really lucky. So, let's put this aside again. Well, here's the circuit board as we've been seeing. The one large transistor, 3 smaller transistors, and the microcontroller, not much else. And then on the back side, all the traces. So you can see how I had to solder that connector on the bottom. And the traces seem to have held up pretty well. A few little drips and mistakes, but it's not bad. Single-sided board, all drilled by hand. Let's see if I can get a better photo of this board without that weird light on the side. Light's much more even over here. Not the prettiest soldering, but I still like the way the copper looks. I don't remember what software I used to design this. I don't know if it was Eagle. It's hard to tell when everybody uses the same file extensions. We could just open them up, I'm sure. So, I know everybody wants to take a closer look at this chip. So this was back when the whole cycle of developing, and you hear people talk about long compile cycles all the time still on big software projects, but this was all the annoyance of a long, tens of minutes kind of compile cycle, but even for really small programs, because you had to wait for the EEPROM here to erase and then reprogram. So I think the eraser I had would erase one of these chips in about 10 minutes with exposure to UV light, and then it would maybe take another minute or so to program it. Let's use a knife on this. Are you gonna servo? Do you even servo, bro? Oh, this label is more stuck than I expected. That's not gonna help. We're gonna have to clean that a little. This is a really interesting packaging technique that was pretty archaic even at the time this chip was produced. So the package was ceramic, and there's this, I guess it's gold plated, I don't know what the base metal is, but this window. And the window, well, the metal surround for the window is made out of some kind of metal, and the window itself is made of quartz, so the UV can pass through it. So as you can imagine, these chips are more expensive than something you'd usually want to ship. I think each of these individual chips was maybe like $7 or $8 at the time. Whereas, they were designed to be something you'd put in like really mass manufactured products, so you wouldn't leave the windowed version in for any longer than you had to. Oh, that's working. So I think these packages are also relatively easy to open because I think they're actually just brazed together. So you can basically desolder the top plate off of the package and get to the die. But because the window, you can see the chip without even having to do that. And I also enjoyed some of the optical effects that you could do, by shining light on the die, you can change the amount of leakage in the analog to digital converter's input. So I had a program that would make the die itself into a light sensor just by charging up the analog to digital converter capacitors, a lot like you would do like a capacitance, like a capacitive touch sensor. But instead of depleting that capacitance with anything externally, it would be the light effectively causing the capacitor to leak with a little bit of photovoltaic current. Because, a solar cell is just a big slab of silicon. Right. There's our cleaned chip. Good old-fashioned microchip PIC16 C745. Let's take a look under the microscope, of course. Let's put this in something. Try to get this as zoomed as I can on this cheapo microscope. Lots of people ask about this microscope. This is the daily reminder that it is a totally generic HDMI 1080p microscope that I got for like $130 from eBay. You can also find them on Amazon. It's pretty good for the price. Ooh, it's starting to come in. Working distance gets pretty bad on this one as you start to really try to zoom in, but it's worth it. Can we get any closer? That's already pretty good. I've lost track of which direction I'm supposed to be turning that. Oh, that's definitely magnify. Whoa, how close can I go? I'm gonna have some lighting problems soon, actually. That's a 0.1 inch pin on the processor. Where did I go? There we go. That's about as clear as I can get it on this scope anyway. For doing this properly, I need a scope with a better lens, I suspect. I mean, I'll stop touching this in a sec. I'm just trying to focus. Wow. Just change the light angle and get some more detail into the surface due to all the diffraction going on. It's very tough to focus this microscope accurately enough. If I kind of shim it with my fingers, you can get to about there. Anyway, now we can't even see the whole die. Let's see, what are those? That's just dust on the surface. Well, I mean, so this big region here is almost certainly going to be our, well, I was about to say flash memory, our EEPROM memory. So that's what we're actually intentionally erasing. This stuff here is likely RAM. Not sure what these two different blocks are. Like maybe they're different. Well, there are different kinds of RAM. There's like a register file and a stack. So maybe one of these is the registers and one of them is the stack. Can't quite resolve down to even individual bits in the register file with this microscope, but it's really close. Anyway, if you're interested in this sort of thing, I highly recommend checking out a number of other YouTube channels that I'm not going to give the full list right here because I'm sure I leave out some of my favorites, but yeah, there are several. I mean, a really classic blog that you should check out if you haven't already is Flatlogic, and they take things apart. And Zeptobars is another similar one where they post really high-res photos and some reverse engineering notes. Anyway, I think that's enough of this for the moment. I don't know what else to do with this circuit board. I mean, I might just hold on to it for prosperity, one of those words. Is it lucky to hold on to old microcontrollers? I think I have some of these chips in unused state also, since I used to like these chips a lot. I used them in a bunch of things. You can see the bond wires down there. Well, if you have any thoughts about what to do with this, let me know. Otherwise, it's probably going to sit in a box of old projects indefinitely until I get tired of it. Alright, so with the archaeology out of the way, now there's just this VFD that I kind of want to reuse. And it's stuck to this foam. That's so weird. Why would it do this? I don't think I glued it. I think this is just the foam being sticky, but I don't know. I'm just trying to gently flex the metal to release the foam from the VFD. Yeah, this foam, I didn't realize it got sticky like this. That's interesting. I don't think I'm going to need or want this in the new case I designed. I haven't quite figured out what the case is going to look like, but I suspect I want to make it out of something that, well, I mean, I want to showcase the VFD really nicely, basically. There we go. That's the thing. That's really pretty. try to get some of this foam residue off the front of the VFD. I don't really care about this box necessarily. Might just donate this to the scrap metal monster. But this, let's clean this a little. This is worth cleaning. This is what I came for. I'm really hoping the seal all around the edges is resistant to this, but I suspect the seal around the edges is like made out of some kind of cement or something. I don't know if silicone would have been around for this, or if that would have even worked. I think the first step here is just to run the display in self-test mode just to see how well it works, and that should give us an idea of how to proceed. And then maybe find a data sheet so we can see what the input format is supposed to be. I mean, it seems like it has multiple format options from the back panel with some. The back panel has some jumpers, which we'll get to in a sec. So I don't think we need a data sheet. I mean, between the code and the schematics in this project, there's plenty of info to go on, but it might be useful to have one. Oh, it might be neat to combine this with neon tubes. This is getting a little further from the realm of this is an easy project to I want to make an artistic contraption, but I don't know. I'm sure I could find some easy ways of powering such a thing. Alright, let's just take a once over with the camera and take a look at this thing before we turn it on. Alright, that's really pretty. So 20 by 2 characters, and I suspect a lot of you have seen the construction behind VFDs before, but to really quickly summarize, it's a vacuum tube that excites these little phosphor squares that glow green. The electrons for this excitation come from some really thin wires, which you probably can't see now, but they'll glow just a little bit when it's on because they heat up. And then those are put under a somewhat high voltage. Like, I think this, well, we can measure the voltage, but I think it's under 100 volts. And that's enough to accelerate the electrons toward the phosphor targets. But then you can modulate which dots light up, both by controlling which dots, like which targets are actually sinking current, and by using those vertical grids to actually mask off individual characters. So that's how this does multiplexing, by actually acting like a vacuum tube and switching current on and off to individual pixels. Kind of reminds me of how TFT LCDs are designed, where some of the switching actually ends up being part of the display technology. This is kind of like an early version of that. So that's why we don't need a pin for every single pixel, just for all the pixels on one column, and then for all the columns, and then for the grid. You can see the fine grid wires over there held under tension by little metal springs, just to hold them tight and keep them from wobbling. That's part of what the noise is coming from. I think those wires are still chiming a little bit when they get mechanically bumped. So, there's not much else to see on the front side. You can kind of see through and see that there aren't really any components under the VFD, which is probably good. And the VFD itself is a couple of layers of glass bonded together with some kind of spacer allowing the lead frame to poke through. So on the back, that's the connector everything comes in over. I think these are pull downs just for all the digital IOs or pull-ups or something. So clearly we have an array of these identical VFD driver chips, and then kind of one main driver which probably does all the fonts and everything else and actually has all the smarts in this thing. And this looks like kind of a, it's probably got a microcontroller in it of some kind, but it's probably kind of like the, it's probably similar, it's probably in the same category as like the Hitachi HD 44780 that runs most of the parallel character LCDs. In fact, I think this has a mode where it's compatible with that. Yeah. So over here on the mode switch side, yeah, we have 9600 or 19200 baud. Intel mode, I think these are in relation to the parallel bus. I think that it's, oh, here we go. Yeah, so there's a parallel bus that you can configure either for Intel, Motorola, or traditional Hitachi LCD controller emulation. And then there's the self-test switch, which is, I think, what we're looking for. Well, let's get a pinout. Maybe, well, I'm going to do a quick search for the datasheet. If the datasheet doesn't show up easily, we'll just get the pinout from the schematic we already have. So, what did we say this? We saw a brand name, right, in the repo? Oh, it was over here. Century VFD? God, it's getting warm. This is the right company. So that's the IEE logo we saw. I thought that was some kind of certification at first, but that's the company name. Click your mouse here. This is old. I guess that's their actual website. Cool, what's the model number we're looking for? 05464, I think. Or maybe 36199. I mean, I suspect a lot of these are going to have the same, like if we find, like if this is a data sheet for the whole family of VFDs, then it might be what we want. And it seems to cover a lot of different tube formats. Five volts. Okay, I guess I need to match these model numbers with what I've actually got. So this should be 2x20. 036x2. Yeah, I don't think this is quite the same model that I actually have. Let's see what the connector looks like on this one, and then maybe look for other data sheets. And let's make sure this matches what we have in the repo. So here we've got 5 volts on 2 and 4, ground on 6 and 10. Oh, I guess we can ignore most of this. So this is broken down by whether the parallel bus is in Intel or Motorola mode, but we're just ignoring the parallel bus. So we're using the two 5 volts. Yeah, 6 and 10, so this matches what we have. Let's go ahead and save this data sheet. It looks like it gives us a busy signal, but serial is what we mostly want. So let's find... Oh. I'm just going to measure to see if these are shorted together, and if so, I'll just use 2 alligator clips to power this up. I assume they would be. Wow, is Tuco watching my tea? Tuco, you watching that tea for me? Let's see if I can get a better angle for the kitty. Oh, that's nice. All right. So I just want to make sure these are connected solidly to each other before I only use one of the 2 available power pins, which isn't something you do if you're designing a board, but just for a test rig, it would be more convenient than adding extra jumpers. Yeah, the powers are connected. And the grounds. Great. Let's try self-test mode. I remember that being fun on this thing. I'll grab the right cables. Oops. I'm not used to wearing this microphone belt pack. I mean, usually there's not much I need to say when I'm just fishing for cables. But, you know, I figured I would end up using some of the audio from this session, so I would give myself more microphone options. Cable. Alright, 5 volts. Oh, Tuco's looking handsome. So those are just some of the available power pins. And this jumper changes the mode to self-test. Keep all the conductive debris at bay. Alright, power supply is at 5. Alright, let's give this some juice. It needs a little more. Okay, it's drawing. Try doing that without ramping up the current slowly because it hit the current limit. Oh, cool. It's identifying itself. It's going to look a little dim next to the bright lights that it's competing with, but it's actually pretty bright. It's drawing 0.63 amps. Let's turn some of this light off. Oh, maybe these would actually help the most. Yeah, so it's pretty nice in the dark, and that flicker is not apparent in person. In person it actually looks quite nice and smooth. Let's maybe help the camera out a little bit. Oh, let's turn this one back on. Man, these things are annoying to film. Not quite like some LEDs, but looks pretty good in person, but it's a little bit of a flickery mess there. I don't really have a lot of options on this camera at this light level. Anyway, this seems nice. Maybe we should check out the datasheet to see what it says about that serial input. Maybe I can stop this down a little bit. I think that might actually be nice. Manual, ooh, manual movie mode, that's what I wanted. Where's the frame? Welcome to this camera. Yeah. Don't know if that's gonna get any better. I mean, really, I want to be changing the exposure, but don't know if it lets me do that while I'm filming. Maybe I have to stop. I mean, I don't know. I don't necessarily want to fuss around with this super much, but if I'm making a project with a VFD, it would be nice to know how to film the VFD. I was pretty sure there was a way to change the exposure while you're shooting movies. Like, you can't make it longer than the frame length, but you can usually make it shorter. Oh, this is the, sorry. I thought that this was the ISO for some reason, but this is completely the exposure. So that's good. We want that to be long. And then ISO. There's my ISO. That's getting much better. Okay. Yay, I'm learning how to use this camera. There's all this stuff that was totally sensible in photo mode that is just different in movie mode that I'm having to figure out. Yeah, and we just want that stop down. And then still flickering a bit, but 30 is as good as I can do. Maybe I can stop it down a little more, or sorry, ISO down a little more. Oh yeah, that seems to be about right. That's like shimmering somewhat annoyingly, but also somewhat cyberpunkly, so, you know. Let's see what that looks like with this light on. Kind of washed out. So usually these are made with dark plastic panels in front of them. I don't actually have any of that handy, but it might be worth seeing what I could come up with. I mean, I don't want to like 3D print a window because that's not going to be optically clear, but if I can find a little bit of kind of smoky acrylic that I could snap in there maybe. But I don't know, it's nice to see the tube. I'm all for improving contrast, but I don't want to hide the tube too much. Alright, let's put the camera back where it was on AV. Okay. Tuco is changing positions. How do I even deal with a cat that changes positions? Alright. Datasheet. So I think we can trust this datasheet. Serial input. What do you say about serial input? It says it takes half a second to turn on. Yeah, maybe I'm not going to worry about the power or the hardware power on super much. I don't know if it's that bad for these to just have their filament warm. Maybe I'll have to do a little research on that. Well, here's all the control codes. That's nice. I think we've already got a Python module that'll do the trick, though. Data cannot be read back in serial mode. That's fine. Ah, serial. Oh yeah, this is full strength RS-232, man. Alright, well maybe we're taking apart an RS-232 adapter. So I had one picked out actually. I was going to use this critter from Adafruit. I think it's the one they sell for programming the Raspberry Pi. This one. Yeah, I have a couple of these, and they seem like they'd be a good match for this. It is from Adafruit, they're cute, they work fine with Linux, and they're not FTDI, which is kind of fun. And they give you power, which is probably fine for driving this. It's maybe a little much to ask, but yeah, I guess I would need to invert a TX if I was going to use that particular cable. So let's see what else I've got in my bin. Wow, Tuco looks really good right now. I'm sorry, you all need to appreciate my cat. That's pretty much what he's for, right? Being appreciated and looking at things and satisfying his feline curiosities. Oh, actually, speaking of Tuco, if we're going to take a brief Tuco diversion, there's a video I need to show you from something Tuco got up to earlier today. It's kind of crazy. I think I have it on my phone here. Oh, so I was in the closet trying to debug a network connectivity issue, which turned out to be an issue with the fiber on the other end. But he was in there. So, I had the ladder out, and I was in there taking a look at the router and making sure it wasn't something stupid. And he was in there with me, and he ended up, climbing up into the ceiling. And this video starts, when I went back out to grab my camera after I decided that he was exploring, he was probably fine, and I wanted it on video. Let's see, pardon me for just a second while I stream this to the computer. Is it channel 3? Yeah. Welcome to my phone. So, not that one. Although that one was kind of nice too. This is what I was trying to show. So... Yeah, that's the closet that has the 3D printers and some of the network equipment in it. Oh, now we've got Tuco here and Tuco in the video. I think there's something he wanted. So there was still this time when we first moved into this place, 2 years ago or so. He was freaked out because he had just been through a bunch and I'd just been through a bunch, and we just moved into a new place, and so he hid somewhere. I guess I never figured out where his hiding space was, and he lost the collar he was wearing when we moved in together. But he was gone for a day and a half, hidden somewhere in the walls, possibly in a place like that. And then he came out and he was fine, and he was just like, "What's up? Where's the food?" He's such a jumper.
You got yourself into this. I was trying to encourage you to come down, and you were like, "I want to see what's up there." Good job, Chico. There and get you. Oh. Hey, too.
Anyway, yeah, so that was my favorite cat video of the day. And that's my phone, and that's my VFD. So I think our options for serial, again, I have some great options for USB to like TTL serial. I've got stuff like this. I've got a couple of those Adafruit cables. I've got some older stuff that does RS-232. So there's this one. It's just generic USB serial converter. You can almost see the chip through the package, but it's not quite. So I'm gonna plug this in and see if this uses a chipset that I would bother using. This one is kind of weird. So I used to be a fan of these back in the day. This is the Keyspan USA 19HS. This is one of the... Oh, what did I do with this? Why was I into this? There was a couple of so I was kind of a connoisseur of USB to serial adapters for a little while because there were a few that I was into reprogramming, since it was a way to get a USB equipped microcontroller at the time. I don't think this was one of those. I think this one might have been a reject from that, but anyway, it was like a nice... I think for a while this was one of the few adapters that actually had a really nice, reliable Linux driver. But I guess I've already got this one hooked up for a particular FPGA dev board that I use, so I could take this thing apart, but I could also use something else. And then I've got this thing, which I don't even know what chipset this is, and it's also like potted in rubber, so I assume I want to be able to power this thing also, so this is less convenient. Yeah, that is also very generic. So let's see what chipset this one shows up as to see if it'll be convenient enough to bother using. Alright, so IO Registry Explorer, and we'll take a look at the USBs. There's the thing, USB serial controller. Oh, it's a prolific chip. Is it a prolific chip that I have drivers for right now? Doesn't look like it. Let's make sure this is like not an ancient chip and something we can actually get drivers for before we build it into this thing. So the relevant identity information here is vendor ID 67B, which is probably, some vendors are large enough they have multiple IDs, but often there's just one. And then their product ID up here, which is just 2. So let's see if we can just find some vendor product IDs for common prolific USB serial converters. Let's just see if that works. Well, PL2303, I guess, is the common one. So they might just tell us the ID. No. Okay, so this is the 2303 is something newer, I guess. So this might be some really... Oh, never mind. Here's 2303. Oh, yeah, I was reading this wrong, sorry. iProduct is not the product ID, it's the index of the product string. So I'm still not really used to IO Registry Explorer, but this is, in fact, the prolific 2303. So that's good. That's a very common chip, so we shouldn't have any trouble using this. We will need to install the driver, which is actually the same driver this chip uses, so I will probably end up wanting to use this on Linux, but for now, let's install the Mac driver so that we can get stuff running on here. So this is the right page. yeah. Oh, Tuco wants to play, and the camera is totally not in the right place. Hey, Tuke. What's up, cat? Do you want bolts? Here's one. Maybe we can try fetching with the fisheye lens. It's really tempting to automate this lens somehow, but I mean, that feels like a solved problem. It is actually kind of nice not having an autofocus that just kind of goes off on tangents without you, though. Alright, Tuke, I gotcha. Maybe that's enough. See if we can have some fetch from that angle. Alright, so since it seems like this serial adapter will fulfill our needs, let's take it apart. Because I don't really want the case as is, and I think I want to tap power off USB. So I really want the board out of this more than I want the entire unit. So let's power this down. Okay. Oh, I thought I was going to get to CAD today. I don't know if I'm going to get to that, though. Probably going to have to take a break from this stream before we open up the CAD. In that case, let me know if you have opinions on what CAD package to use, because oh, actually, let me grab my vise before I get too deep into that. Oh, where is my vise? Oh, actually, maybe I just want vice grip pliers for this. Anyway, yeah, I was going to ask for if you have any feedback on CAD packages. I know I've asked this before, kind of more in general on Twitter, like what do you want to see? But I guess in this case, I have an opportunity to ask specifically for this project, does anyone care what CAD package I use? I was thinking about, I guess I was torn between Rhino and Fusion 360. Since Fusion 360 is pretty capable and it's something that a lot of people are using, so it would be nice to add kind of educational content that works with it. It's also something a lot of people have access to. It's, but then I have complicated feelings about it because I'd rather not support the kind of giant subscription-based monolith that Autodesk is becoming. So I would rather, support something that's not kind of trying to become a monopoly, I guess. So there's also Rhino, which is something that I have just used because I like it for a long time, but it's expensive and not as many people use it. So I don't know. I was probably going to use Fusion 360 for this project just because it would be nice to get some more practice in that. And I've done. Oops, sorry. Sorry about that. Yeah, I've done some stuff in Fusion 360, like the, if you saw that little like magnetic pressure sensor widget thing that I did for the Boldport Club Engineer Superhero Kit video, that was all Autodesk Fusion 360. And I've done some other kind of smaller stuff that I haven't really shown off in that, but this doesn't. Oh, it does have latches. Okay. I was just gonna like squish it apart, but I think I can use the spudger on it. Spudger is in the other table. Ow! I didn't need that toe. Metal spudger maybe. I'll just bring several spudgers over. Something in this pile will get us into this. Start with the finesse, maybe. It looks like there are just some plastic clips holding this together, actually. But it felt like it might have been glued also. And usually my first reaction to glue is to get the vise and just snap the glue apart. But that is actually easy. There, open sesame. Cool. So, it looks like this circuit board is almost designed for a USB connector to go in there also. Oh, I was waiting for it to autofocus, but it's not on autofocus. Okay. So there's the actual PL2303 chip. That was the footprint. It looked like it might also be suitable for like a USB Type A connector, so that's interesting. Then I assume that would be the line driver. What line driver is that? ZT213. Let's give this a once-over under the microscope just for the fun of it. But this seems like what we want. I just want to desolder pretty much. Well, I want to leave the chips, but I want to desolder this connector, and I think I want to replace this wire with something nicer. I don't think I want to keep the wire. Oh man, I think I might actually have to take a restroom break. Usually I try to time these so I don't have to on stream, but the tea is my culprit. I blame the tea. So I'm going to leave you with Tuco for just a sec. Well, I'm probably going to leave you with Tuco really wanting to play Bolt and not being able to. Alright. Probably gonna have to wrap up the stream pretty soon anyway, just because it's getting late here, but... Well, and also because I do want to get into CAD, but it's probably too late to start the CAD right now, because I don't think I have enough energy to think about how to do a new part of the project at the moment. But let's just take a look at this under the microscope. Let's make the microscope way less zoomed. Okay. That is the line driver chip, ZT213. I don't recognize that manufacturer. think that's Z-Tex. Looks like an unused space for an EEPROM or something similar. And then the connectors kind of soldered with the board in between the two rows. There's the PL2303. A few unused resistors down there. I wonder what that's for. All right. Well, maybe we can at least unsolder a few of these and then wire it up to the VFD. I'm going to leave the USB cable on for the moment just because it's more convenient for testing. But I want this DB9 connector gone. So in order to sacrifice the connector and hopefully not damage the board, I'm just going to cut the pins at the top. I feel like just any kind of knife through there would probably be enough to cut it apart at this point. Alright, let's clean that up a little. Just gonna flow a little bit of fresh solder onto here to help these come up. That was the thing that usually means sensor error. I wonder if this is not in as tightly as it should be. Just debug my soldering iron without burning myself. That seems to be in. Maybe that's this thing's way of telling me the stream should be... Oh, come on. Is that right? Okay, I think the sensor was just loose on the soldering tip. That was a different beep. That was a happier beep. I think he wants to go outside. Tuco, it's too late to go outside. It's pretty late here. He likes to hang out in the hallway with the other warehouse cats. But if he wanders off and I just want to go to bed, then that's going to be annoying. Whoa, there is some really grody flux in there I just melted. It smells really foul. Let's turn on that fume extractor. So this VFD, being that it already has a built-in serial interface and everything, we just need 3 wires. We just need ground and 5 volts. They both need to be able to carry a decent amount of current. And then our fairly pokey 19200 baud full-strength RS-232 serial connection. And I think I'm not going to worry about having a soft power off thing. I mean, I don't know, I'll have to do some research, but I have to imagine that thermal cycling these tubes would have to be, you know, as bad, or probably at least comparably bad to keeping them hot for longer, so I don't know. I think I also had that transistor to turn off the VFD to help, you know, for USB spec reasons, you know, you're not really supposed to use that much current until you ask for it. So, I mean, if I was making a board and if I had a microcontroller, I would definitely throw some kind of load switch on there so I could turn on and off the VFD. But at this point, I think I'm trying to keep the project a little simpler than that and just not even have a microcontroller and just use this modified serial thing. So maybe I'll just do that. I know I could have a microcontroller and the modified serial thing. I mean, I'll think about it. I mean, that would be one option, is to have a little backpack board that sticks on to this thing and has another microcontroller, or possibly even just, I mean, you could do this with like an analog circuit, like a little RC timer, but it's almost easier to do it with a microcontroller nowadays. And it's certainly electrically simpler. But yeah. Let's see if we can at least get some signs of life out of this thing before we end the stream. I'd like to put some characters through this thing. So we need some wire. Let's maybe put something with female jumper pins on here, since I have a bunch right here on the desk that I could use for that purpose. Yeah. Although these are a little melted. Let me grab some fresh ones. Breadboarding supplies, aisle 2. So these wires look so little. Let's maybe use something slightly less skinny. Let's color code it even. Alright, so I just snapped off this little thing, which is so I just had some bulk like rainbow ribbon cable female headers like this, and I snapped off red, black, and brown, so we can use red and black for +5 and brown for data. I need a wire stripper. I feel like I almost know the pins off the top of my head for the serial port. I know ground is 5 and transmit and receive are 2 and 3, but I always forget which one is which with 2 and 3. Oh, these wires are really thin. I hope that, well, I don't know if I'm going to keep these, but I worry a little bit at running half an amp through these little tiny wires. We can see if there's any appreciable voltage drop, I guess. So, I should be able to see that. So, I think we've got 5 over here, so I think, oops. So if you see that pin on the left, that one's connected to the ground plane. Let's get rid of this QC sticker. Alternate place for a crystal. Oh. Looked shorted when it wasn't. Maybe I'll clean that slightly. Guess it might be easier to look up the pin out than to reverse engineer it. Slightly. Tuco, you still want to go outside? It is 11:30 here, and I should probably be trying to get some stuff wrapped up soon, just because, you know, I feel myself getting tired and all that human stuff. I don't know, I like Tuco's sleep cycle. He seems to be able to kind of just turn it on and off continuously. Alright, oh man, this is not making it cleaner. Let's, yuck. Get a fresh one of those. Alright, and let's just look up a reference for this. tp9pinout.com. That's silly. Okay, transmit is pin 3, which is what I wanted. So we want pins 3 and 5. So 3 will be brown in our current color scheme. Alright. And then 5 volts, of course, did not appear on the original serial port, so we're just going to snag that from wherever it's convenient. And I guess for that reason, that wire is probably going to end up being longer, unless we can find... We're probably not going to find 5 volts on that side of the board easily. So I probably just want that to be longer. So I'm going to solder both of the power wires first, and then go back and trim the other one to length and solder it on. Oh, I need that to be on microscope land. Now it's just in the way of my view of the microscope screen. It's fine. Just tinning these wires. Hey, Tuco. I'm just going to try to put these the same spot. Probably going to have to do this over when I rewire it, but... Tuco, what do you want, boy? Okay, so that looks much more convenient in the shot than it actually is, but that's what matters. Oh. Tweezers, maybe? I feel like this wire is that soft PVC stuff that if I grab it too close with tweezers while it's hot, it's just gonna melt. Oh, actually that solder joint is probably fine for the moment. I'll just do the red one. I think this is temporary anyway. Just want to test this serial adapter and just see some signs of life from the display. Alright, and this one I think is actually going right to the middle. So... yeah, this cat is such a dog. I do actually need that to be slightly more in focus for me to solder with it. Beep. Delicious. Yeah. I think I did not make that cleaner, but... Not a great joint either, but yay, temporary. Alright. Now let's have the pinout for this VFD back. Did I totally just miss it? Am I getting that tired that I'm just missing pinouts? I know it was a weird pinout. Oh, there it is. Alright, serial 14. Alright. So this will be mostly the same. So ground +5 and serial. So 10 is the ground we're using, serial is 14, 12, 14. Okay. And I'll take this off of self-test mode. So now it should be accepting full strength RS-232 at 19,200 baud. Wow, it even goes down to 1,200, I just noticed that. 1,200 baud. Alright, let's hook this up through like a USB extension cable and power meter. And see if we can just spit some characters out at it. Trying to at least set this on something so it'll be somewhat flat. These headers stick out a little bit farther than the stick vise is tall. Oh, and the PCB is actually pretty thick too. So let's do that and sit that on top of just some random thing. I hear you, Tuco. Okay. A couple more doodads from the pile of USB doodads. Need a power meter and a little extension cable. I don't know if I've decided which of these current crop of power meters I like better. That's the shortest extension, maybe not. I want this to actually work with extensions of less short lengths if possible, but you know, first things first. Oh, here's actually a reasonably long one. I guess we'll see if the voltage drop is a problem. So I'm going to plug this into a powered hub that has a pretty beefy power supply attached. not necessarily the same computer I'm going to be using this on, but, you know, test setup. Alright, so here we've got 5.28 volts, nothing attached. Hey Tuco, chill out, okay? Oh, it's blinking. See that blinking cursor? Let's dim these lights a little. Let me just turn off this one. And turn this one down. Alright. Hey Tuco, I hear you, but I'm in the middle of a thing. Oh, do we have to finish installing those drivers? Did I not actually do that? Hey Tuco, what do you want? I was gonna go track him down with the camera, but he's heading back here. Mac OS. Tuco, you're being all sharp. Oh, for serious? Fine. Maybe before we get a character on the screen, you get to watch me reboot my computer. Tuco, are you gonna play while we reboot? Oh yeah, I just noticed the chat laughing about the VFD being next to an OLED. Totally. Alright, I guess I do need to reboot. According to this thing, it probably just... I mean, the funny thing is, like, there might actually be reasons for it to reboot if you were removing it or upgrading it, but for adding a new kernel module, I can't imagine a legit reason for it to be doing that. Hey Tuco, where's a bolt? Tuco. Still blinking away. Oh, here we go. Hey Tuco. How noisy can I be when I type? Alright, do we have a serial port? I think it's still booting. That hit his food bowl. Okay. Terminal. Oh, maybe let's turn the camera back on. I mean, the camera's on, but I mean, that's what I mean. Hey Tuco. Man, this little cat sure does generate a lot of interrupts. Come on, TTY dot. Oh, that's generic. Kind of like the driver didn't bother actually checking based on serial number. I hope that doesn't cause problems later. I mean, I don't think I'm going to end up keeping this on this machine. I think it's going to be on the other Linux box anyway. go. Huh. Okay, I'm gonna slow this down a bit. Whoops, that's not what I wanted. Oh, why is the N key not none parity? Why is L none parity? Okay, that's what I wanted. No flow control. Oh, I've got a character. Ah, nice. Let's maybe stop the camera down a little more so that we can see that more clearly. Oh, or maybe I just need less of this. Yeah, I think I do need to stop the camera down, otherwise it's just going to keep compensating. Let's do that. I'm still not used to the movie mode controls on this. There we go. Ah, yeah. And now I can adjust the fill light. Just a little. Great. So we can type on this thing. Oh, it even scrolls. And we get backspace. Cool. Yeah. Well, I think this is almost a good wrap-up point. One more thing I do want to try is to use that Python library that I had written ages ago. I want to see if I can just modify this to work with the serial port really easily. Let's see, GitHub, some old thing. Hey, Tuco. Oh yeah, what's this saying? This is still running off a USB just fine. 0.67 amps. Voltage drops down to 4.85 and it doesn't seem to care. Hey, Tuco. He's such a cat. Alright, I'm just gonna clone this. Still blocked. That's not really gonna work unless I quit minicom and leave the port open. Yeah, I don't know why that's not working. Oh, that's under the thing, but I was trying to just hex dump some junk to it. But probably some flow control issue or the port settings getting changed when the device gets opened. Hey Tuco, where's the bolt? Oh, this is kind of a large repo. I don't know why it's downloading so slow though. And I guess that's at GitHub's end. Let's just double check that this is working. I mean, yeah, it's doing a speed test during a stream, but That seems fine. Wow, that's a lot higher than it usually goes. Maybe no one else is using it right now. Anyway, I'm gonna guess this problem is not on my end. Oh, jeez. Okay, maybe I'll do that later, and in the meantime, I'll see if I can grab a zip file. Oh, the zip file's also taking a while. Maybe GitHub is just slow. Oh man, yeah, something inside GitHub is slow. I'm gonna have to download all these that I care about. Oh, this is annoying. Surely I have a checkout of this somewhere else on my LAN. Oh, let's change that. Hey, Tuco. Aren't cats awesome? Yeah, I do have it on this computer. I can just SCP it over. Stop that. Cancel everything else. There's only cats. Okay. Oh yeah, you can see the little doodad is counting milliamp hours for me. Just a little shimmer. It's kind of cute. Okay, did you just copy successfully? Okay. Wasabi. Oh, I had a bunch of junk in my working copy over on the other machine. Okay. So I just want to hack up this Python module so that instead of using my crazy kernel thing, it just opens a serial port. Whoa, this uses numeric Python? That's old school. I might have to convert that to NumPy. Yeah. That might be less easy than I thought. Well, it should be... What is that stuff called? Isn't that... It's been a while since I used numeric Python. Maybe that's still available. I mean, I know NumPy has pretty much the same API, so maybe there's just a compatibility shim, or maybe it's just trivial to change. I also forget what I used that for here. Oh, it was this. Probably other stuff, but... Hey, Tuco. Are you trying to tell me something? Hey, Tuco. Well, I don't know how deep I want to wade into this software thing right now. Because I think some of the interesting stuff I wanted to try does require that. And I have to update Homebrew. Alright, well maybe we'll play some Bolt with Tuco and then wrap up the stream. Hey Tuke. Where's your toy, honey? There's one. Whoops. I know I already have NumPy installed on most of my other machines, but I guess not this one. I forget whether it's best to install this with Homebrew or with pip. I guess I could just search the actual website. What do they recommend? Pip. I can do pip. I just noticed a comment from chat that Dr. Toon wants a Servo AF shirt featuring a really, really big servo. I would like that too. Oh, you know, I've got some like line drawings of a servo I made a while ago for a documentation project, but I don't know if that would quite be servo AF. It was just kind of a normal servo. Oh, I'll upgrade pip later, thanks. Is that real? Yay, okay. I also want PySerial. Do I have that? Yes, okay. Okay, let's just see if I can change that to NumPy. I think I was only using really basic parts of it, so I don't know why I have import star, but whatever. Let's also take out the I/O controls and import serial. Let's stub out a bunch of this stuff. Lights. I hear you, Tuco, and I feel you on my leg. What do you want, boy? Where's your critter? Where's your plasticky bit? Where's your bolt, Tuco? Oh, they blend in so much. I've tried giving him bolts that are more contrasting colors, but I don't think he likes them as much. They're just too easy for me to find then. Let's see. I seem to remember this. Yeah, let's actually open. I'm just reminding myself, yeah, this is what I want. I pretty much just want to say what the baud rate is and what the port is, and then call it done. So I'm going to quadrat. That would have been a good name for something. Is that really all this is going to take? Are there any more I/O controls? So I'm not using glob anymore. That was for finding all of the devices that this kernel module offered, but I'm just going to hard code the particular serial port we care about. And we have power control, which I'm just going to stub out for now. Okay, let's see if any of the examples work. I guess first I can just try importing the module and see if that works. Ooh. What is VFD widgets? I made a text layout system? What even is this? Widgets and surfaces with gravity and stickiness? I've written so much software that I've forgotten about. This might actually be handy though. I might have to go look up how this works. Looks like I can make a bunch of widgets that kind of stay on the screen and do their own updating. Clock. Is VFD echo a simple thing? It sounds like it would be simple. Ooh, maybe it's not simple, but maybe we can try it anyway. I guess it's just for putting text on the screen. But it has like ellipses and fading. Wow. Well, that seems like a NumPy issue. I don't know where this thinks it's getting NumPy from. This must be some terrible import star consequence. Oh no, that is in MI6K. Oh, I think this is just something else that changed in NumPy. I think the type system changed. Yeah, let's go figure out what that changed into. Yeah, NumPy type codes, I think, are different. Oh. Maybe they're just lowercase? I think that might be the difference. Yeah, it's just those two. Whoa. I think I just printed a blank string. Huh. Well. Ooh, I scaled the brightness to floating point. Nice. Well, you can kind of see it get brighter. All right. Graph. Oh. Oh, what was that? I'll just install this for now. Oh, numeric. I just want to see some cool graphs. Let's see if that does it. Well, oh, Tuco, I know this is boring for you. This one's doing all this custom character stuff. Save space. Is that like some copy on write stuff? I'm gonna see what happens if I ignore that. Yay! Well, this is going to be a good starting point. I didn't realize I already had this much. I mean, I knew I wrote a bunch of code for this, but I didn't realize it would be stuff that I could still use. This actually is reasonably alright. I guess the LED stuff isn't really going to help, but... Ooh, there's the auto-scrolling. Yeah. And you can see it on the lower brightness to try to save display life. Oh, and it switched pages. Okay. Yeah, so I guess that's what the widget library does. Wibble, 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 wibble. Yes, what else? XMMS. Anybody else remember that? It was like the Linux version of Winamp. Get the current song title. Interesting. I know I had a spectrum analyzer somewhere. I don't remember what framework I would have written that for, though. I mean, I thought that I thought this was a spectrum analyzer, but I guess not. So it's like a spinny thing. Maybe that fit into LCD proc? No. I think that was its own thing. Oh, maybe that was... I know I had a spectrum analyzer for this. Oh, I should probably wrap up the stream. I might come across the spectrum analyzer at some point. I would have expected it to be that MI6 or that XMS thing, but... Oh, you know, maybe it's not in tests. Maybe it's somewhere else in that Wasabi project. I should see what else in Wasabi uses MI6K. Oh, there's a Wasabi plugin for the MI6K. Of course, because there needed to be a plugin system for something only I was theoretically using. Anyway, that's in the firmware. Yeah, I wonder if that had anything useful in it. Ooh. Freevo. That's the thing that we were building on. It was like MythTV. I think it was earlier than that, though. Huh. A CVS version of LCD proc. Oh, okay, so that was something that they were using that I was trying to integrate with, I guess. So it was like information about the currently playing file. Ooh, LED animations. Power management, menus, OSD. Okay. I don't know where my spectrum analyzer was, but I'll probably come across it at some point. In the meantime, we have Wibbles. Do I have any more cool examples? That graph thing was kind of cool. Oh, what is HGraph? Don't think I tried that one. I assume it's just the horizontal version. Oh, missed one. And yeah. It's an okay example of making custom characters, I guess. Uses numeric Python to fill in the character cells quickly. That's not bad. That's also using a trick where, because there's like a 1 pixel gap between every character cell, but this pattern incorporates that into the bar graph, so it's a lot less noticeable. It's kind of cute. How does that actually work? So the main program. So this thing makes the bar graph class. I guess we're using, I mean, I would expect it to use all 8 custom characters. Oh, actually for this one it wouldn't need to. For this one it just needs 3. For the vertical, I guess it was using all 8. Hey Tuke, do you just want to play? Alright, I think we've reached the end of another stream. Current consumption does change depending on how bright it is. It's a little under half an amp now. But the USB hub has been happy with it this whole time. And it's kind of silly, the things that I did for USB spec compliance on the original version of this. But more innocent days. Well, thanks for tuning in, and a special thanks to everyone who's been supporting my stream with hardware and comments and Patreon dollars. It's all been super helpful. And I'll continue to do what I can to put information and projects out there where people might find them and like them. And if you have any comments, be sure to send them my way. I usually hear it and assume it's somewhere really close by, and then it's just right out of my line of sight somewhere. Let's have a moment of full screen VFT there. Happy hacking, everyone.